Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering College, Anandi, Pune. Today, discussion on neural network architecture and its implementation using Tensorflow module. Next, let us start with first we'll discuss the basic concept of neural network. Now, neural network is a computational model inspired by biological neural network in human brain process information. The structure of structure of the neural network, it contains the number of units in neural network. There are n number of layers in a neural network architecture. Now, as you can see in this diagram, now this is the input. This is the simple basic architecture of neural network. Here in this example, you can see this is the input layer. Now here there are two hidden layers are there, first hidden layer and second hidden layer. In first hidden layer, there are three units are there. These are also called as nodes and neurons for the computation purpose, which are processing or which process the input given by input layer. Then this output of the hidden layer 1 pass through the hidden layer 2. There are also three neurons are there. Then after computation, the output displayed in output layer. Now there are different types of neural architectures are there, like feed-forward neural network, convolutional neural network, recurrent neural network, generative adversarial network, autoencoder. All these networks are using the basic architecture of neural network. Now, whenever we are performing the training process on neural network, there are two steps, that is a forward propagation. The forward propagation passes through the network to get the output. Once we get the output, then we are calculating the error by using the loss function, and then to reduce the loss function, we have to perform the optimization where we are implementing the back propagation algorithm from right to left to reduce the error by updating the weight and bias value. There are various n number of applications of neural network. Neural network including the image recognition, speech recognition in healthcare for diagnosing the diseases from medical images or predicting patient outcome. Different types of examples are there where we can use the neural network architecture. Now let us discuss. Now their main focus in this session, we are discussing on the implementation of neural network using TensorFlow. Now this is TensorFlow is an open source library which is used for the implementation design of the different types of ML and deep learning model. Here we are using the Keras API under TensorFlow. Now here in this example, we are using pre-trained dataset that is called as the MNIST dataset, which is used for the handwritten digit recognition example. Next, one more model is here, one more function we are using that is called as the sequential function. Now here using this sequential, we are creating the network where we are adding the n number of layers sequentially, where the output of previous layer will be the input to the next layer. Two more modules we are importing, that are dense and flatten. Dense means the fully connected layer, fully connected layer or hidden layer in neural network architecture. Flatten, which is used to convert the matrix into a linear vector. Also, we are using the two categorical to convert the values into categorical format. Now let us discuss. Next step is the load and prepare the data set. As here we are using the already trained data set, that is the MNIST data set. Now here we are loading the data set for training purpose, and for testing purpose we need to load the data set. Now here this X-train and Y-train for the these are the trained data set, and X-test and Y-test, these are the test data set. Now here we are loading this data set. Now here we can also display the labels of unique labels from both classes. Now these are the unique labels from the both classes 0 to 9. Labels in both class sets are same. Now let's third step, that is to build the model using TensorFlow. Now here we are using the model is equal to sequential. We are creating the model using sequential function. Now here in sequential we are adding one by one layer in a architecture. As we have discussed the architecture. Now here this is the input layer, this is the hidden layer, and this is output layer. Now in hidden input layer, now in for whatever input we have received, now in the form of array matrix, this input we need to convert into one dimensional 1D linear vector using flatten function. Now this input 28 by 28, because MNIST data set contain the images where its size is equal to 28 by 28. As it is grayscale image, so there is only one one channel. So these input images, these input pixel information in array, it is represented in linear vector. Now this input is passed through, its output will be passed to next layer. Next layer is that is a dense layer. We are adding the hidden layer. Now hidden layer with 128 neurons. Hidden layer with 128 neurons and ReLU activation function. ReLU activation function, which is used to discard the negative value and which introduce the non-linearity in data set. Now if value is negative, if from previous layer if you receive any negative value, that value set to 0 using ReLU activation function. Last layer is dense layer. Now in the last dense layer, this is the last layer, that is the output layer. Last layer in neural network, it is represented by dense, means it is output layer. Now here there are total 10 units or 10 neurons. 10 neurons means these are in output layer. We are defining the number of classes, means there are total 10 classes are there, that is 0 to 9. These are 10 classes. Activation function is softmax function. Then whatever result, whatever values we are received from the previous layer, from this previous dense hidden layer, now these values will be passed through the activation softmax activation function, where the softmax activation function generate the probability value, and this based on this probability value with respect to each classes, then we are predicting the output for the selected input. The probability generated by the softmax value, the addition of with respect to all 10 classes, it should be 1. Next, fourth step is compiling. For compiling, we are using optimizer is equal to Adam. Then loss categorical cross entropy we are using, because there are 10 categories are there, 10 classes. So here we are using loss is equal to we are calculating that loss value using categorical cross entropy, and evaluation matrix, that is the performance of the neural network model, we are evaluating using accuracy matrix. Then train the model. Now in train model, that is the fifth step. Train the model, fit x train comma y train, epoch is equal to 5. Now here the this example is trained for the 5 epoch. Batch size is 32, and validation data is equal to x test comma y test. Now here the training is completed, and then you can check the accuracy and performance of the model using evaluate function. Now evaluate function for the test data set. Now here test loss and test accuracy. This evaluate function return two value, loss and accuracy, and this evaluate for the test data set. Now here you can check the accuracy of model is 0.97. If you increase the number of epoch, then there may be probability to increase the accuracy of your model. You can also display the one single image from the data set. Now using matplotlib. Okay, now here x train and y train, you are loading this data set. Now you can display this image using imshow function, and here you can display, this is the one sample input image. This is all about neural network architecture and its implementation.